Moving on to the next part of Module 3, Topic 2, Lesson 2. We're in Activity 1, and we're on page 415. Reasoning about equations. Habits of mine are to look for and make use of structure, look for and express regularity in repeated reasoning. When you determine the value of a variable that makes an equation true, you solve the equation. Recall that a solution to an equation is a value for the variable that makes the equation true. You can use a double number line to represent and determine the solution to an equation. So it says solve the equation. This is our worked example. So in this example, they're showing us a double number line. We have 0 here and 15. Up here we have x plus 10. It says you want to determine the value of x, so the expression x plus 10 is equal to 15. You can move the barbell 10 units left to locate x. This means subtracting 10 plus x minus 10 is x. This is how you'll see it in Mathia. Here they're showing it like this. You're subtracting 10. So you'll be subtracting 10 from each side of this barbell. Since the barbell represents that the two expressions form an equation, you have to subtract 10 from 15 also. 15 minus 10 is 5. How can you check that 5 is the solution to the equation? Well, we can substitute 5 in for the original. So to go back to the x, you have to get rid of the 10 or slide back 10 paces. So you have to slide back 10 here, slide back 10 here. It would put us at just x and 5. And to check it, we have x plus 10 equals 15. We would substitute the 5 in for the x. And it checks out. So which property of equality do we use here? We use the subtraction property of equality. Okay, pause if you need to finish writing, and I'm going to flip the page. Okay, so it says use a double number line to determine a value that makes each equation true. Identify the property of equality that you use for each equation. So we have p plus 10 equals 17. So there's no really right or wrong spot to draw it. We know it needs to be kind of a distance away from 0. P plus 10 equals 17. So this is just like the original one. For us to get back to p, we would have to subtract this 10. We would have to subtract 10. Let's say that puts us here. Actually, it would probably put us down here a little bit. And if we subtract 10 from the top, we get just p. 17 minus 10 is 7. And it says check your solution. So p plus 10 equals 17. 7 plus 10 equals 17. 7 plus 10 is 17. It is true, so we use the subtraction. I'm just going to put P-O-E, property of equality. Subpo. 14 plus Q equals 32. That's how kids last year started to say that. It was a lot of fun. Okay, so 32, let's say 32 is here, and that is equal to 14 plus Q. I could rewrite that as Q plus 14 because I can switch the order. So the commutative property, I could switch the order. And then to move back to just Q, I'm going to have to subtract off 14. And when I subtract off 14 from 32, what do I get? So do you need to write that down? I like to model whenever we need to borrow or regroup. You can't do 2 minus 4. So you have to cross off the 3, make it a 2. That 2 becomes a 12. Now we can do 12 minus 4 is 8. 2 minus 1 is 1, so we have 18. So we're saying our solution is 18. I should kind of write that up here. What we're saying is P equals 7. That is our solution. Our solution here is Q equals 18. So rewriting, and I'm going to rewrite the original. 14 plus Q equals 32. 14 plus 18 equals 32. Substituting our value that we just determined, the 18, and for Q, 4 plus 8 is 12. Carry 1, 1 plus 1 is 3. 32 equals 32. That works out. We're still using the subtraction property of equality. 90 equals x plus 64. So now they've put the equation, kind of flipped it. The equal sign comes much earlier here. So normally we would say x plus 64 equals 90, but we've written it the other way around. It's not a big deal. It still means the same thing. So we have x plus 64, and here we have it equals 90. So this is the same as this. So x plus 64 equals 90. To get to just x, I'm going to have to subtract off 64 to get me to just x. So 90 minus 64, here's a regrouping opportunity. Can't do 0 minus 4, so 8, 10. Now 10 minus 4 is 6. 8 minus 6 is 2. So we have 26, so we are saying x equals 26 as our solution. We're going to substitute it back into the original equation. 90 equals x plus 64. 90 equals 26 plus 64. Let's add that over here. 26 plus 64. 10. 1 plus 2 is 3, plus 6 is 9. So we do get 90 here, equals 90. It checks, and we did the same thing as above, so still the subtraction property of equality. We'll see you on the next video.